Okay, so we're going to learn about our first hypothesis test, and we're only going to use the p-value approach, so it should be a pretty streamlined process. The key to knowing what hypothesis test to use comes down to assumptions and conditions. All right, so we look at assumptions. In this case, for testing and claiming about a proportion, our assumptions are simple random sample, 4 conditions for binomial distribution are satisfied, and these mathematical operations. All right, so if you can verify those assumptions, they become conditions. If you can't, then we just assume that they're true. Otherwise, we can't perform the hypothesis test. All right, so once those are in place, we know what hypothesis test to use. Then we can state the null and alternative hypotheses. All right, the possible null involves an equal sign. I'll show you what that looks like in a minute. The alternatives would be everything but an equal sign. So less than, greater than, or not equal. Well, in this case, greater than, less than, not equal. Then you choose an alpha value. All right. If the alpha value is given in the problem, then you just go with that. If not, then you could choose whatever you want. The most common one selected is 0.05. So when in doubt, just go with 0.05. All right. And so step 3 is the first part of drawing a conclusion. If the p-value is less than the alpha, then we reject the null hypothesis. And then once we have that, we could state the conclusion, the final conclusion, in words following this particular template. All right. So it's all calculator work. Once you get a particular value known as the p-value, you use that to draw a conclusion. That conclusion follows a particular template. You can't deviate from the template lest you lose credit. Right? So be very, very careful about that. There's no, I don't know how to describe it. There's no, we'll call it playing fast and loose with the rules here. All right? Like, don't overthink this. If you can't fit your conclusion into this template, then you done did it wrong. All right? That's really all it's going to come down to. So let's take a look at an example on the next page, and I'll show you how this all plays out. You'll notice in your handout that the diagram, this little flowchart thingy here, or attempt at a flowchart, is not there. I made this after the fact, so I'll take it as a typo. You know, if your document doesn't have this in it, then by all means send in that typo, and I'll give you credit for it, bonus point. All right, so the example, it is claimed that apples are the most delicious fruit on the planet. To test this claim, let us determine if the majority of the population responds apples when asked what they think the most delicious fruit is. A sample of 4,500 people are randomly selected and polled. It is determined that 2,475 people chose apples as the most delicious fruit. Using a 0.05 significance level, so they're flat out telling us, there's no guesswork here, test the claim that the majority of the population finds apples to be the most delicious fruit. All right, so majority of a population. So let me get my writing tool going here. Population as in P. Majority better than 50%. All right, so this phrase here, majority of the population, is saying that P has to be greater than 0.5. All right, so we have that. So we're ready to rock and roll there. Now it's just a matter of getting the calculator approach down and seeing what's what. So our null hypothesis involves an equal sign. Our alternative hypothesis involves a greater than, less than, or not equal symbol. All right, so we just discovered that we're asked to test a claim. The null and alternative hypotheses will be the claims. We just found the alternative hypothesis, so P greater than 0.5. The null hypothesis is going to be the same expression. Same ingredients, but different equality or inequality. In this case, it's going to be P equals 0.5. All right, so it's made up of the same stuff. The only thing that differs is one has an equal sign, one has a greater than symbol. All right, so the alpha value is 0.05. That was given. Told us the significance level is 0.05. That's alpha. The calculator test is going to be a one prop Z test. How did you know that? Well, it said it on the previous page, right? But really, the one prop is the key indicator. We're dealing with one proportion. I want to know some relationship having to do with a single population proportion. All right, the population proportion of people who chose apples to be the most delicious fruit. So stat, we go over to test. So left arrow once, right arrow twice, however you want to get there. One prop Z test. On mine, it's option 5. I believe it's the same on yours. All right. So you'll have a display that looks very much like this. The P sub O value is going to be whatever you used in your null hypothesis. All right, so let me just bring it in. This guy here is the P sub O. All right, so that O, or 0, if you want, is actually going to correspond to the value that's used as a subscript in the notation for the null hypothesis itself. All right, so this is the P associating itself with that. All right, so it's the understood or assumed population proportion initially. Now, we collected some information to see if that is in fact true or false, so that's where we're going. All right, now they told us that we had a sample of 4,500 people, so N is 4,500 people. The number of successes is 2,475. Now that'll give us a percentage if we divide the two, but we don't need to do that. We just need to pop these numbers in here. Now generally, the problem is going to give you the N value first and the X value. When you put it in your calculator, you're putting in the X value first, then the N value. All right, so 0.5 for the assumed P, 2,475 for the X, and 4,500 for the N. All right. The alternative hypothesis for our purposes is only there just to give us an idea of what to plug in for in that last row there, the prop row. I want a greater than PO. All right. So my alternative has a greater than symbol, so that's where we're at. We hit calculate, and it gives us some information, lots and lots of information. The key piece of information that I want is the P. Now, you're like, which P? The P with the little hat on it? Just the P? Like, is that the same as the P initially? Or like in the null and alternative hypotheses? What's going on here? The letter P might be one of the more overly used variables in statistics. It means a lot of different things. In this context, it means the P value. All right. And that is, if you go back to the last lesson, the probability of making a type 1 error. Right? It's also, really, if you're thinking about it in simplistic, almost simplistic terms, you're saying, like, all right, my chances of accidentally rejecting the null hypothesis is what? What is the probability of accidentally rejecting the null hypothesis when I shouldn't? Well, here it's saying it's 9.852 times 10 to the negative 12th power. That's what that E negative 12 means. So 9.852 times 10 to the negative 12th power. All right. So again, that E negative 12, that's all that means. So in decimal form, this is the same as 0.000345678 8, 9, 10, 11, 9, 8, 5, 2. So 11 zeros followed by 9852. All right, so I wrote that small because I knew it was going to get big. Slash, I accidentally started writing it small, so I had to kind of go with it. All right, so incredibly small p-value. All right, so that's telling me that it's okay to reject the null hypothesis. All right, so I'm going to reject the null hypothesis because my probability of mistakenly rejecting it when I shouldn't is so small that if I do reject it, there must be enough reason for me to say so or to do so. All right, so there is sufficient evidence to reject the claim that, and then here we state the null hypothesis in words. So whatever the null hypothesis is in words, we address that first. The population proportion of people who chose apples is 0.5. All right. All right, so that's the null hypothesis in words. I mean, it's not pretty. I mean, it's not going to be a literary masterpiece. At the alpha significance level. Dang it, I meant to leave a blank here. At the 0.05 significance level. So we're going with doing it that way. All right. The alternative hypothesis, excuse me, the alternative hypothesis is that p is greater than 0.5, but we got that by identifying what mathematically a majority would be represented as. So here I would say, therefore, the claim that the majority of the population chose apples. I'm kind of getting a little lazy here. As the most delicious fruit, you know, there's not really enough room for that. I'm just going to say chose apples. I think it's pretty clear what I'm talking about based on the context of the problem. That's going to be true. And that goes back to this idea of the null and alternative hypothesis. So what I'm going to do is I'm just going to use X marks and check marks. Let me just increase my thickness here. If I'm saying that I'm rejecting the null hypothesis, I'm saying, oop, I guess I got to turn this off. I'm saying, nope. I'm rejecting it. It's no good. So that's bad. Get rid of it. If my only two choices are HO and HA, then that means that if HO is no good, that HA is my winner. All right? So that would mean that this guy is false and this one would be true. All right? So sufficient evidence to reject the claim of null hypothesis in words at the 0.05 significance level. Therefore, the claim that the majority of the population chose apples is going to be true because I've eliminated the possibility that the null would be true. So the alternative is the one that has to be true. All right. So that's our first hypothesis test. You know, they take a little bit of getting used to, and you know, there's definitely a lot going on here. But really, you'll see as we move forward, it boils down to state your null and alternative hypotheses. Know what calculator approach to use. Know what alpha value you're working with. And then p-value conclusion that's going to be very consistent from here on out. All right? It's really just going to boil down to, am I using a proportion or am I using a mean? So that's what the next lesson is going to be on. All right? So that's where I'm going to end this one.